In question 7, we again have to do some balancing of reactions. But we're dealing with something very different here. We have a pair of redox reactions. And redox reactions are a lot more complicated than balancing normal reactions. We also want to pay very careful attention to whether we're under acidic conditions or basic conditions. So in order to properly balance a redox reaction, we need to split it into the two half reactions. Our first step in balancing a redox reaction is to balance any elements that are not hydrogen and oxygen, which in this case is chromium. We can balance our chromium by putting a 2 here. Next step is to balance oxygens by adding water. We have 7 oxygens on the left side, so we need to add 7 water molecules to the right. Once we've balanced oxygens, we need to balance hydrogen. We balance hydrogen by adding H+. In this equation we have 14 hydrogens on the right, so we need 14 hydrogens on the left. Finally, we balance charge by adding electrons. The right side of our equation has 2 chromiums at +3, so a total charge of +6. The left side has a total charge of +12. To balance our charge, we'll need to add 6 electrons to the left side. So we've now balanced our first half reaction, the chromium side. We now need to look at our second half reaction, which involves iron. Now this equation, this half reaction is a lot more straightforward to balance because our ions are already balanced. There's 1 on each side. We don't need any hydrogens or oxygens. So all we have to do is balance charge. And we can do that by adding a single electron to the right side. Before we can recombine our two half reactions, though, we need to balance the electrons. There's 6 electrons in our first half reaction versus 1 in our second one. So we need to multiply the entire second reaction by 6. Once we do that, all of our electrons will cancel out and we can combine the two half reactions. Now, if we were working under acidic conditions, we would now be done with this question. But recall, this question specifies basic conditions. In order to have basic conditions, we need to get rid of all of the H+. And the way that we do that is by adding an equal number of hydroxide ions to both sides of the equation. Now these 14 H+ and 14 hydroxide will actually combine to form 14 water. We're still not quite done though, because we now have water on both sides of the equation. And so we can subtract out any water that's on both sides. That means we're going to be getting rid of 7 water molecules over here and 7 over here. So our final balanced equation will look like this. 7 water plus Cr2O7 2- plus 6 Fe2 plus reacts to form 2 chromium 3+ plus plus 6Fe3 plus 14 hydroxide. And that 6Fe3 was missing. It should have been added in here as we had it in our second half reaction. Our second redox reaction to balance is actually going to be a little bit more straightforward. The reason for that is we're working under acidic conditions. So that last step that we did with the hydroxide, we don't have to do here. Again, two different half reactions. NO2 minus reacting to form NO3 minus, and then MnO4 minus going to Mn2 plus. So in our first reaction, we don't need to worry about any non-oxygen or non-hydrogen elements. Same thing for the second half reaction. We can see our nitrogens are already balanced and our manganeses are already balanced. So first we need to balance oxygen by adding water. We need one additional oxygen on the left side here. In the second half reaction, we actually need 4 additional oxygen, so we add 4 water molecules. To balance hydrogens, we add H+. We need 2 H+ on the right here. And because of the 4 water molecules down here, we need 8 H+ down here. We now need to balance electrons. In the first half reaction, we have -1 on the left and +1 on the right, so we need 2 electrons. In the second half reaction, we have +2 on the right and +7 on the left. So we're going to need 5 electrons. Now in order to balance out the electrons, we're going to have to multiply the first half reaction by 5, the second half reaction by 2. So we can now see that our electrons balance. And we can now add the 2 half reactions together. So on the starting material side, we have 5 NO2 minus plus 2 MnO4 minus. Now we have 5 water molecules on the left, but 8 on the right. So we can cancel out the 5, and we're going to be left with only 3 water molecules on the right side. With H+, we have 16 on the left, 10 on the right, so we're going to be left with just the 6 on the left. And then the product side, 2Mn2 plus 5 nitrate plus 3 water.